is found in between, giving a lot of cushion between the two big bones. Okay? That hyaline that creates the articular, that is the only spot you find it. It's right there on the edge of the bone, where two bones connect. If you need more protection between those bones, you get the fibro, like you would need between the knees. So we have our fibro cartilage. Elastic cartilage, like you see with the ear and the nose, okay? Lots of elastic fibers. Collagen's present too, but elastic is the more dominant. Once again, proteoglycan matrix, and it gives some rigidity, but it's also plastic. Well, I shouldn't say plastic. Elastic, okay? Bad thing about these, this one, it doesn't stop growing. This is why when you look at older people, their ears are big and their noses are big. Because it doesn't stop growing. It keeps going, like the intertarsal bone. Ears, epiglottis, lots of elastic fibers present. Okay, now, the next supporting connective tissue. This is probably my favorite. Bone. This is a good example. Okay, so everybody see the blue right here? That's trying to show you that articular cartilage that forms over the edge of a bone. If we do this number, see all this stuff represented in this peachy color right here? That's representing your fibro cartilage, okay? Between two long bones that have to articulate.
Is that middle of the MCL and outside the ACL?
Showing right there, yes. And the outer, the ACL. Now, bone. Can everybody see where they're trying to show this little red area in the middle and this area to the outside? Okay? They're trying to show you spongy bone, the little red area, compact bone. This area to the outside of that red area. Okay? Bone is considered hard connective tissue because it is. All right? This time, our cells are termed osteo. So now, I'm going to end up with connective tissue wrapping, all right, that will contain my cells that will give rise to this. So that means I'm going to have the ability for an osteoblast. Once again, it will be a cell, the immature, okay, that has to lay down the matrix, the hard part of the bone, and when it gets stuck, it's now an osteocyte stuck in its lacuna, its home. This tissue also gets to have the osteoblast. And what does the blast do? Winnie? Stop. Class, I'm sorry. Okay. Break it. Break it down. So this one gets to also have the osteoclast. Get me straight there. Because bone is storage for calcium and phosphate. Both of which are needed by the body. So bone is continuously built up and broken down. The matrix definitely gives strength and rigidity. We find that in cases of bone, it is helping protect and support other tissues and organs. For example, the skull is protecting some very important tissue. The vertebrae, some very important nervous tissue. The rib cage, some very important organs. Just saying. Okay? So,
The coccyx.
huh?
The coccyx.
The coccyx, well, the pelvic region, okay, would be protecting those reproductive organs. Here's one of the things that's interesting. In the matrix now, which we'll be getting more into, all right, the matrix now, because it is hardened material, it's called hydroxyapatite, which is my calcium phosphate. It's termed inorganic because you don't see carbon being present. The organic portion is the collagen. Now let me explain to you this matrix. Have you ever seen anything being done with concrete? Like a form being made for concrete, forming a building, forming a walkway.
Rebar.
Rebar. Everybody familiar with rebar? When concrete is poured, you cannot just simply take something, pour it in, and expect it to stay that way. You have to form the shape you want, okay? And then you have to come along and use, depending on what you're working on, okay, metal bars. And they're called rebar, okay? And the person who's working on it comes in and every so many places places rebar. They could have another bar crossing, depending on how much strength they want to give to that concrete. Our bones, the collagen fibers, are doing this. And as osteoblasts start riding or moving on the collagen fibers, as they are simply sliding along on the fibers, they're secreting that matrix. They're secreting the calcium phosphate. Does that make sense? So as they move along, secreting the matrix, they eventually get stuck and end up in their lacuna, where they're now a site. But let's say, because remember, their matrix was calcium phosphate, okay? Let's say the body needs some calcium. An osteoclast will come and do like this tent over an area of the bone and begin to release chemicals that will break that bone down. And when it breaks it down, the calcium and the phosphate go into the bloodstream. And we now have calcium for the body. Guess what two systems are dependent on calcium? Do what? My nerves and my muscles. This is why we refer to bones as being areas of storage, because they can store it and release it. So, osteocytes, and we'll get more into this, the osteoblast will lay down the matrix, eventually get stuck, and it'll get stuck in a lacuna. The two types that we have are the spongy and the compact. Spongy bone is very important to the structure of bones. Not only is it special in its structure, where it just looks like little spicules, little branches that occur in between the middle of the bone. Those are called trabeculae, and the reason that they're termed spongy is because they look like a sponge under the scope. Note how they're trying to show that the spongy bone, where it's found. For example, in a long bone, like the femur, okay? We find it in that articular head, the neck, and all the way down the middle of that bone, of that long bone. And then surrounding this spongy bone, surrounding the spongy bone would be my compact bone, which looks like this. Now, did you pick up on the other term in the video called lamella? All right, well, they tried to show that there was a central canal, which is where you would find the spongy, and my bone marrow, okay? Surrounding that in what they term concentric, that bring to mind anything, in a circle, okay? Lamella, lines, okay? Layer, 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 layer. Do you kind of see where it looks like a nucleus here, nucleus here, nucleus here, nucleus here? And then if you come in another layer, nucleus, 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 nucleus. Come in another layer, nucleus, nucleus, nucleus. Come in another layer, nucleus, nucleus. Y'all kind of see that? That would be layer to layer to layer to layer to layer. and about 7 to 8 of them